Hello friends, now what you're looking at here is a box and a bag, and there will also be a second box that we'll take a look at later in the video. And I scored these things at one of Cologne's flea markets just the other day, and for the entirety of all the items that you're going to see here, I only paid around 15 euros, which was practically a steal. Well, that is, unless that guy used to operate a meth lab or something like that and just wanted to get rid of his stuff. And the majority of the items inside these containers comprise an assortment of professional chemistry/pharmacy lab equipment that, as far as I know, was once used in a pharmacy here in Cologne, even though a lot of the items are actually new and seem to be unused. And the miscellaneous electronics that you see me unpacking here right now are not in the focus of this video. I got them for a couple of cents each, and they might appear in future episodes. This is really about the lab equipment. And even though I refreshed a lot of my older chemistry knowledge over the course of the last week, I am not a chemist, of course, and there will be lots of people in the audience that know more about the things that we will see here than me. So what I'm going to do in this video is to go through all of these items step by step, try to name them and try to briefly explain their purpose. And in some cases I could do that right off the bat. In other cases I had to do a lot of research online, but I also bought these two older German books here, which deal with chemistry lab equipment, and I also paid less than 10 bucks for both of those books. But there will still remain a couple of items that I don't know anything about really, and that's where you come into play. So if you recognize something, please give a time marker and a short description what you're talking about, because there will be a lot of items in this video. So I will now first simply unpack all of the items and give a brief description of what I'm seeing. I will first only name a few of them, but then reveal their names and purposes later in the video. So before commenting on that, please watch the entire video. We will then also try to figure out how these items worked together, because a lot of them were actually sold not as separate items, but as sets for different experimental setups back in the day. So this first lot here basically comprises a loose assortment of differently sized pipettes, very small ones for just a couple of milliliters, but then also these larger ones called volumetric pipettes, in German Vollpipetten. And we will see more of those for even larger volumes over the course of this video. And in the next step I removed this metal frame and these plastic plates here, which have a couple of holes in them, as you can see, and I will explain what these parts comprise and what they're good for in just a minute. And this next part, for lack of a better term, I would describe as an angled connector piece, a glass tube that has ground glass joints at both ends, and we can find inside a little tube that ends in a drop-shaped piece of glass, and I would guess that this is probably part of some kind of distillation apparatus. The next item is a condenser, to be more specific a Arlin condenser, in German called Kugelkühler or Arlin Kühler, and on one end it has a ground glass joint, and on the other side we have what in German is called an Abtropfrohr, which means as much as dripping or draining pipe. And this next part here, this time apparently even still in the original packaging, is what is called a dropping funnel, in German Tropftrichter, which is the exact literal translation of that. And on its top it has a ground glass joint with a plug in it. And it is a cylindrical type dropping funnel with a so-called stopcock, in German called Küken or Glasküken, which is a little ball valve that can be used to open and close this outlet tube here of the dropping funnel. This next device is another condenser, a simple cylindrical one known as a Liebig condenser, or in German Liebig-Kühler, and one of the little tubes through which the coolant is flowing is bent around, and that could mean that this was intended to be installed in a diagonal position. And the next item is this apparatus here that consists of a kind of a double-walled test tube, the outer one of which is around 3 centimeters in diameter. And then we have a steel rod that forms a ring at one of its ends, which is then led through a glass plate that is sitting on top of the outer test tube, and we also have a ground glass joint there. There's also another hole, and then we have a metal clamp that also has a bolt on it, and that can be used to put those two together. And I'll tell you more about what this is good for later in the video. And this next piece is simply a large glass laboratory funnel with an outer diameter of around 18.5 centimeters at the very end. And this small glass here contains a white disc-shaped object which I identify as a filter, and this particular type of filter is called Fritte in German. And here we have a special kind of flask where the actual hull of the flask is drawn down inside, forming a narrow tube that goes almost way down to the very bottom of that flask. And there's also a little hole in the wall at the very top of this flask. I have no idea though what this flask is good for, and I can't wait to learn it from you guys. And this little red rectangle right here marks the label that you can read on this flask, and that is something that you will find often on German chemistry lab equipment. And what it reads is Duran Schott Mainz Jena Glas, and Duran is just a trade name, also Jena Glas, for basically the German version of what you know as Pyrex in America. And that glass is manufactured by a company called Schott in a city called Mainz. That's why it reads Duran Schott Mainz Jena Glas. And this is basically just borosilicate glass, very similar to what you get as Pyrex in the United States. And the next part looks like something of a specialty item, and I would describe it as either a dropping funnel or a burette, but with an additional glass tube that is branching from the upper part of that funnel. And we will have to see if I can find out what kind of experimental setup this was intended for. And the final item from this first box is this measuring instrument here that consists of a S or U-shaped glass tube that is apparently filled with mercury and is blocked by a ball valve from these lower glass tubes here. And when I first unpacked that, I didn't really know what this is good for, but I'll explain that to you by reading a text from one of my new books later in this video. So now that the first box is emptied, we can go over to the bag and take a look what's inside. Now this rather large, thick-walled, pot-shaped glass container here is called a vacuum desiccator, in German Vakuumexikator, and in this case as well I'm going to tell you more about it by reading a small chapter from one of my new books later in the video. Other than the desiccator, I also found some miscellaneous parts, like this tubing, another small filter, this crucible made of lead, and two different plates with a hole in it that can be put in top of that crucible. Then also this casting form here, the purpose of which I will reveal to you later in this video. Two plastic plugs, and parts of what seems to be a membrane filter, some ground glass rings, and some other small parts that I have not yet been able to clearly identify, but maybe you can help me out with that. So with the first box and the bag emptied, we can now take a look at our third container and see what's inside. And the first item is, you might recognize it, another Arlene condenser, this time larger than the first one though in the more usual form, with two ground glass joints. But other than the other condensers that were made by a company called Wepa, this one was manufactured by Brandt in West Germany, so that must have been at least before 1990. And by the way, these numbers up here on the ground glass joint stand for NS, that is Normschliff, which means standardized grind, and then 2932 means largest diameter of the taper 29 millimeters, length of the joint 32 millimeters, and the slope in mathematical terms of that taper is 1/10. So at 10 millimeters length the diameter is reduced by 1 millimeter. And the next items are what I would identify as a 500 milliliter volumetric flask, in German Messkolben, but without a ground glass joint. The next item is what I would call a burette, or burette in German, only that it doesn't have any markings which would enable you to read off the volume that is inside the burette itself. And this item here looks very similar to the first burette, and as you can see, it also comes in its original packaging. And the next item appears to be yet another testing apparatus that consists of a round bottom flask with a very long drawn neck and a ground glass joint at the top. And then we have something of a test tube, but with a glass joint at the top that can be inserted into that flask. But there are holes in that test tube part under as well as over the joint. And it goes on. We find another smaller Liebig condenser. Then what I identify as a round bottom flask for 250 milliliters and another one for 100 milliliters, both made from Duran borosilicate glass manufactured by Schott. This glass tube that gets very narrow at one end, and it has a sticker that says that this belongs to a setup intended for column chromatography, but I'm pretty sure that the other parts of that setup are missing. Then this part here, which has a very narrow glass tube, I'm pretty sure that I have seen this before, but I do not know how it's called or what it's for. Please help me out. Then we find some more small pipettes, some old tubing, and then we have a last package of bubble wrap in which we will find even more items. First, a volumetric pipette for 30 milliliters, which has a stamp on it that I interpret as a date code from 1974. Then also a 50 milliliters volumetric pipette with a 76 on it. And I guess that we can take this as a hint that probably all of these items are from somewhere around the middle of the 1970s. Even though, as in this case, a lot of the items seem to be completely unused. The next item looks like a very long test tube, only that it has another second glass tube wrapped around it at its bottom end, and then you can find a small air hole inside that second layer. The old handwritten sticker says, Apparat zur Bestimmung der Siedetemperatur, apparatus for the determination of the boiling temperature. And now we come to the last object. Again, as it seems, another test apparatus for a very specific purpose. It is an intricate system of glass tubes that seems to be somewhat circular in nature, and it includes another Arlene condenser as well as a kind of three-way ball valve. And we'll just have to see if we can somehow find out what kind of experimental setup this is supposed to be used for. So now that we have taken a brief look at all of these objects, I will now try and do my best to explain and explore the purpose and functionality of many of these objects. And I'm doing that based on the books that I have bought, on some online research, and on some of the information that I got from those mysterious stickers on many of the items. I'm sure though that there will be people in the audience who know exactly what these experimental setups and test devices here are intended to be used for, and I can't wait to read your comments on that. So let us start with these parts here from the very beginning of the video. What we have is a metal frame and then two sets of 3 plastic plates each of which again holds 60 holes that are of different sizes for the two sets. And what this is a capsule filling machine, Kapselfüllgerät in German. And how it works is that you place a set of 3 of the plates onto the frame as I'm doing here, and then 60 capsules are put into the holes. You then lift off this top plate here, which separates the two halves of the capsule. You can then fill your material, or whatever material is supposed to go inside, into the bottom part of the capsules, and then you can put the top back on and press it down, and that is how you fill 60 capsules at a time. And I have put a link in the video description that links to a video that shows how this works with a similar device. And now let's take a closer look at that vacuum desiccator. As you can see, a lid is sitting on the desiccator, and that lid doesn't move 1 millimeter no matter how much force I apply to it in no matter which direction. And I think that that is because there is some desiccator fat between the ground glass surfaces of the lid and the actual desiccator. And that must have gotten very hard over the course of the years. So what I'm doing now is to apply some hot air all over the desiccator in order to sort of melt that fat. And ta-da, you can see that that worked out quite well. Here you can see the fat on the ground glass surfaces. And I guess this blue stuff is a kind of drying agent. And in here we also find a ceramic plate manufactured by the Rosenthal Corporation. In the next step, I now remove this blue agent here and I clean off the fat and all other dirt and grime on the desiccator. And in the last step, I dry it. But we haven't spoken yet about what the desiccator is actually good for, and for that, let's take a look at the books then. Okay, so these are the two books that I bought for this entire undertaking. The first one is titled Chemische Laboratoriumstechnik, that means Chemical Laboratory Technology, by Walter Wittenberger. This book was written in 1942, and this is an issue though from 1963, and I guess that Wittenberger is actually from Austria. The second book is called Laborgeräte und Chemikalien, that means Laboratory Equipment and Chemicals, by Gerhard Meyendorff. And I guess that Meyendorff, who wrote several books on chemistry, especially for schools, was actually living and working in what was then the eastern part of Germany. This book was published by Aulis though, and that is in Cologne. For the desiccator, let's take a look into the Wittenberger book. And here on page 152 we find a chapter on trocknen, that is drying, and that is the main purpose of the desiccator. And down here we can find depictions of two different desiccator types, and you can see that the one that I have scored here is definitely one of this left type, and it says here Abbildung 191, Exsiccator nach Scheibler, and that means picture 191, desiccator as devised by Scheibler. And here we have a paragraph that tells us what desiccators are good for, and let me read that in German first and then just spontaneously translate that. Der Exsiccator enthält einen Raum, gewöhnlich der untere, zur Aufnahme des Trockenmittels sowie eine Platte zum Daraufstellen der Gefäße mit den zu trocknenden Substanzen. And that means that the desiccator has some space, typically the lower portion of it, where a drying agent is to be placed, as well as a plate which serves to put containers on it wherein the substance to be dried is placed. It then says, der Rand des Exsiccatorgefäßes und der Deckel sind aufeinander geschliffen. Der luftdichte Abschluss wird durch Einfetten der Schliffflächen erreicht. That just means that the surfaces of the lid and the bottom part of the desiccator have ground glass surfaces, and that fat is used in order to make that joint airtight. It goes on. Oben oder an der Seite befindet sich bei manchen Ausführungsformen ein Hahn zum Anschluss an eine Vakuumpumpe, beziehungsweise als Entlüftungshahn zum Ausgleich der Druckdifferenz, die entsteht, wenn heiße Geräte im Exsiccator langsam auskühlen. And that means that either on top of or on one of the sides of the desiccator there is sometimes an outlet for a vacuum pump, but that can also be used to simply vent the desiccator when hot items have been placed inside, and that vent is then simply used to equalize that pressure difference. And on the next page we also find a short paragraph about the drying agent that we saw inside the desiccator. And let me read that in German first again and then translate. Ein regenerierbares,
Hochaktives Füllmaterial für Trockentürme und Exsikkatoren ist das Silikagel. Durch Zusatz eines Farbindikators ist der Sättigungsgrad und damit die Notwendigkeit einer Regenerierung sofort zu erkennen. A regenerative, highly active filler material for drying towels and desiccators is the silica gel. By adding a color indicator, it is instantaneously recognizable when it is saturated with water and thus necessary to regenerate the drying agent. Im aktiven Zustand ist dasselbe blau und schlägt nach fortschreitender Sättigung mit Wasser nach rosa um. Die Regenerierung erfolgt in einfacher Weise in einem Becher Glas durch Erwärmen auf 100 bis 200 Grad Celsius. In its active state, it, the drying agent, is blue and only changes to pink with an increasing degree of saturation with water. Its regeneration is accomplished by simply heating up the drying agent in a beaker to 100 to 200 degrees Celsius.
And indeed, as I was cleaning up the desiccator, a small remaining portion of the drying agent came in contact with some of the water, and here you can see that it has clearly become pink. So the information from the Wittenberger Buch turns out to be exactly right on this.
And the next item that we have to talk about is this rather odd mercury-filled measuring instrument that we saw earlier in the video. And in this case as well, Wittenberger knows an answer. As you can see here we can see depiction number 319, vacuum meter. So that would be vacuum meter, maybe mercury vacuum meter, I'm not sure. And down here we have a paragraph. So let me again read that and translate that. Das Vakuummeter ist eine Vorrichtung zur Messung des Druckes, wenn dieser kleiner als eine Atmosphäre ist. Er stellt ein abgekürztes Barometer dar, besteht also aus einem luftleeren Rohr, das mit Quecksilber gefüllt ist. Wenn es mit einem nahezu luftleeren Raum in Verbindung steht, ist die Höhe des Quecksilbers in beiden Schenkeln ebenfalls nahezu gleich. The vacuum meter is a contraption for measuring pressures below 1 atmosphere. It is basically a shortened barometer, consists thus of a tube empty of air but filled with mercury. If it is in contact with a space that is nearly completely evacuated of air, the height of both quecksilber columns in the two legs is also almost equal.
So until now, the books really helped a lot, but from this point on it became easier to research the required information online, because the manufacturer of many of these testing setups, WEPA, that is WEPA, is still in business today, and they have a website where you can still buy a lot of the same things. So do you remember this contraption here with this double-walled test tube and the steel rod in the middle? Well, it turns out it is still sold under the name Apparatur zur Bestimmung der Erstarrungstemperatur, and that means apparatus for the determination of the settling or solidification temperature. But other than that, I have found really no description how this works. So the solidification temperature of what is to be determined here, and why would a pharmacist even need to do that? If you know it, please comment something. And remember this shiny metal object here? Well, I was right on the money with casting form, but I never would have guessed what exactly is to be cast here. It turns out that it is actually a casting form for suppositories. And believe it or not, but this part alone sells on eBay for about 4 or 5 times what I paid for this entire lot. And now the next step was to figure out how the different condensers and burettes and so on fit together and which of them is part of which experimental setup. Now that became a little easier because of the stickers that were on some of the devices, but I could only read them partially and I wasn't sure if they were all correct. But I think that this condenser, this flask, and this part, which I called something like a burette, fit together and that they form this apparatus here, which is for Bestimmung des Wassergehalts. That means determination of the water content. But again, I do not really know how this works, except that it is some kind of distillation apparatus, and I'm again not sure why you would need that and the water content of what you would typically determine as a pharmacist. And here is another part that I forgot to show you before, because it was the only part that was actually broken when I bought it. And I think that the three things that you can see here formed this apparatus here for the determination of the boiling temperature or range of the boiling temperature. And again, I'm not really sure how this worked, other than that there has to be a thermometer, I guess, that has to go through the cork that you can see here in the picture. And our single most complex item of the day is something that I also recognized on the website of VEPA. And you can see that it is an apparatus for the determination of the content of essential oils or Ethereal oils. And I'm again not really sure how that works, and maybe someone can tell me about that. And there remain even more open questions concerning this apparatus here that, as the sticker says, is for determination of the melting temperature. I couldn't find that online, even though I found descriptions of similar setups. I'm not really sure what is missing here, and the melting temperature of what is to be determined by using this setup. Then I'm also still wondering about this lengthy test tube thing here and this weird flask and some other things as well. So this is pretty much all that I could find out within a couple of days. And I just hope that there will be some people in this pretty large audience of mine by now that can tell me more about all of this. And I hope you like this little excursion into the world of chemistry and pharmacy, and I hope to see you soon.